So we've already talked about what biological anthropology is, but it's actually helpful to zoom even farther out and talk about science and what science is. Science is simply a process where we're trying to get a better idea of the natural world. We want to produce reliable information about natural phenomena. We have a couple simple things we're trying to do here. First, we observe, then we generalize those observations, and then we want to verify that what we actually saw is true. When we do this, we want something called empirical evidence. This just means experimental evidence. So here we want to observe and make an experiment. You can actively manipulate your environment, or you can also do a naturalistic experiment where you're paying attention to all of the variables, and then when you compare things, you're making sure you're comparing things that are similar. You want to find data that you can write down, observe, and that you can share with more than one person. It's important in science that whatever you're looking at, multiple people are able to observe the same thing. Of course, there are a couple things that aren't scientific evidence. Hearsay is one of them. So if you heard that thing on the internet, it could be true, but it could also be not. That's when you want to go and look it up and see if you can verify what they said for yourself. The next is revelatory evidence. If something is revealed by a deity, that's not really observable by more than one person, so that does not qualify as scientific evidence. And lastly, your emotions. As important as they are not scientific evidence because only you can experience them. They are valid for many other things. They're just not scientific evidence. In science, we want to be rational, or we want to have logical reasoning. Unfortunately, we're not good at that. There are many fallacies when you're having an argument with someone. The most common one I think I run into is the straw man, where you're misrepresenting someone's argument because then it's easier to argue against, or ad hominem personal attacks. We want to make sure that we avoid all of these when we're talking about science. The other thing we want to do is we want to be a skeptic. We do want to question everything around us because that allows us to see, oh, maybe that is incorrect. Maybe this is a bias. Maybe someone was just mistaken. So you want to question people's assumptions. You want to question the evidence they have. And you also want to question their explanations. You also don't want to be a jerk about it. If someone does have the correct qualifications, they probably know what they're talking about. But there is a delicate balance between blindly accepting everything and questioning. There are a couple of biases we want to be aware of in science. First is confirmation bias. Everyone does this. I do this. People naturally seek out things that confirm the things you already believe. And people actively avoid contradictory evidence. So when you are looking at something in a scientific vein, you want to make sure you look at the contradictory stuff even more so than the evidence that supports what you already believe. There's also the self-serving bias where people attribute successes to personal efforts and failure to external sources. This might remind you of someone. We want to avoid that in science and in life in general. In science, there are many different biases that we can have, perceptual biases when we're evaluating evidence. You want to be really careful when you're evaluating probabilities because, a 2% risk is a little bit more than some people believe. And we also want to make sure we don't have any biases in what we're actively perceiving. In science, we just want to make sure that we're doing a good job and that what we communicate with the rest of the world is what is actually going on. Because of all of these things, that's one of the reasons science is constantly changing. I know some people take it to believe that, oh, everybody has a new opinion. It's different than yesterday. Science must be terrible. But that's how science works.